Hey, do you want to make games but don't know how? Don't worry, I got you. Welcome to the fourth part of the Beginner Game Dev series. In this video, we'll be creating our first script to allow the player to interact with the game objects. Let's go. Now we got a ball that bounces on our platform, but it's not much fun. Let's make this into an actual game and let the player control the platform. In order to do that, we need to create our very first script. Before we create a script, let's make sure you have an Integrated Development Environment, or IDE, installed. To do that, we're going to go up to Edit, Preferences, select External Tools on the left, and make sure you have Visual Studio or Visual Studio Code if you're on a Mac selected. If you have a different IDE, that's fine, but for this lesson, we're going to be using Visual Studio. Alright, so go ahead and select your platform, and on the right-hand side, we're going to add a component. You could also create the script in the project view, but then you'd have to assign it afterwards. So we're going to create it directly on our game object by hitting Add Components. We're going to type Player Platform, and then hit Enter, and then hit Enter again to create the player platform. Pay attention to the capitalization because it does matter. Awesome. Now we have our first script created, and we open it by double-clicking on Player Platform. Might take a minute for it to load if it's the first time you're loading Visual Studio, so just give it a second. Welcome to your first script. Notice the class name is Player Platform. This is the name of our script. Mono behavior means that we're going to use methods from Unity. This is a mono behavior script, so we get the ability to use a start method. We don't need to use the start method for this script because we don't have anything that we need to activate before the script starts. So for this purpose, we can delete the entire start method. Awesome. Let's go ahead and create our very first variable. Variables are used to store data that can be referenced later in the script without having to set that value over and over again. So we can set a specific value, for example, how fast we want the player to move the platform, and store that in a float variable. A float variable stores a number with a decimal place. So we'll type float, and then we'll give it a name. We'll name this one platform speed, capitalize the S in speed. Now to set the value, we're going to enter an equals sign. We're going to set it to 5F. Awesome. Other examples of variables would be an integer, where you could store a whole number without a decimal place. You could also store string variables, but we're not going to get into those just yet. We're going to stick to just our float. Now that we got our variable for platform speed, let's go ahead and capture when the user presses A or D on the keyboard. And to do that, we create another float, and we'll call this one player input. Then we'll say equals input.get axis. We want to get the horizontal axis because we want the player to move the platform left and right. So to do that, we're going to put in quotation marks and type horizontal and capitalize the H in horizontal. Put a semicolon at the end to close out the statement. You may have noticed I also put a semicolon at the end of the variable. Every statement in C#, you need to put a semicolon at the end to close the statement out. Now we're capturing player input. We're saving it into a float value, which is either going to be a -1 for going left or a +1 for going right. We'll show you the player input in just a second, but next I want to show you how we can apply this value to our game object. So if we go back to Unity and we look at our platform, notice over on the right hand side we have a transform and a position. What we want to do is we want to move the X position to the left, going negative, or to the right, going positive, depending on what key the player enters. So going back into our script, what we can do is type transform. So we're going to go into that transform, then dot position, and this position, if we look at it again, is a vector 3, which means it has 3 values, X, Y, and Z. So we need to say plus or equals new vector3, open parentheses, and we're going to set the x value to player inputs. We don't want to change the y value, so we'll leave that alone. And we don't want to change the z value, so we'll leave that alone as well by setting them to 0. Now, we're not going to close the statement out because we still want to apply our speed. So we're going to multiply it by platform speed. And because everybody's computer runs at a different frame rate, we want to make sure that every user moves the platform frame rate independent. That way it's always the same speed. To do that, we need to multiply this whole thing by time.delta time. And make it look a little nicer, put a space in there. Awesome. Close it out with a semicolon, and then hit save by hitting Control S on your keyboard or going up to File and Save. Awesome. Let's go ahead and test this out and see what's happening. We go back over to Unity. Notice player platform is attached to our platform object. We hit play. Boulder's falling, press A or D on the keyboard, and it's moving. Awesome. We could also use the arrow keys. Now, you might be a little confused as to how we're actually getting that input, so we'll stop real quick, go back to our script, and look. And you say, well, input.getAxis has nothing to do with A and D and arrow keys, so how do we configure that? Taking a closer look at the player input system, we can navigate back to Unity, go up to Edit, Project Settings, and select Input Manager, and expand out Axes. Here we can see there's a section for horizontal, with left and right, and A and D keys. Awesome. Please note, this is the legacy input system. It is the most basic and easy to implement. At a later date, we'll go over the newer input system. It's a little too easy to bounce this ball on a square platform, so let's make things a little more difficult. Let's create, by right-clicking in the hierarchy, 2D object, sprite, capsule. We'll go ahead and slide this capsule down. Make sure you're on the Move tool, pressing W on the keyboard and in the scene view so you can move this. If you're in game view, you're not going to be able to move it down. All right, let's go ahead and rotate this sideways, changing to Z to 90 degrees. And then we're going to add a collider, we'll call it a capsule collider, 2D, and then we can add a script, the script that we just created, which is player platform. Go ahead and delete the platform, and we'll just focus on this capsule. We're going to center it for the start of the game at 0 and negative 4.5, maybe negative 5. There we go. And we can change the color on this one back to blue. Awesome. Now you'll notice when we play with this, if we lose the ball, game is basically over. So let's fix it so this ball automatically resets. So there's a couple ways we could do it. We could create a script on the boulder, but we really don't want the boulder to worry about when it's out of bounds. Instead, we can create another object that when the boulder interacts with it, will reset it. And then we can visually see where that object is and tweak it a little bit until we get it just right. So if we zoom out, we can see our camera bounds are right here. And the player platform is going to be moving on the horizontal within this area. So we want to create a new object so that way we can see it. We'll create a square and we'll call this reset zone. And let's go ahead and center it at 0, 0, 0, and then we can slide it down below our platform. So you can put it way down if you want a longer delay, it doesn't really matter. We'll put it right here for now. And then we'll press T on our keyboard where you can expand this out, or you can just go up to the scale and we'll scale it up to 25. Awesome. You know what? We go crazy. We could make it 50. Then let's add in a box collider. Box collider 2D. And just so you know, the box collider is stretched across this entire square. Let's uncheck the sprite renderer, and there you go. If you zoom in, you can see we got these faint green lines. That is the collider. So you don't have to have the sprite renderer on, but it is a nice visual so that way we know where our reset zone is at. Now, we don't want it to actually collide with the box collider. We just want it to trigger a script. In order to do that, we need to select this is trigger option. Now we can create a new script, collapse these components. We'll create a new script and we'll call this resetter. Hit enter, enter again, and open up your resetter script by double clicking on it. Now with our resetter script open, let's go ahead and clean this up. Don't need this comment here, it's unnecessary. Let's add in another variable. So unlike a float variable, we can add in a Unity specific variable. And we're going to add in a game object variable so we can store a reference to the boulder. So that way this reset zone knows what interaction to look for. It's looking for a trigger whenever the boulder interacts with it. So we need to store a reference to that boulder. Now we could make this a public field. That would allow any other script to access this game object, and it makes it viewable in our inspector. Instead, what we can do is make this a serialized field. We make it a serialized field. If we go ahead and hit save or Control S, we go back over to Unity, we'll see that we now have a variable called boulder on our resetter script. Now we can go ahead and select our boulder and drag it into this slot. Now it's storing a reference to the boulder. Going back to our script, we can leave the start method because we're going to use it later, but we don't need the update method. Instead, we need a method that's built into the Unity SDK that's called onTriggerEnter2D. So now anytime something enters our trigger area on our reset zone, we can get that collision information and do something with it. So in our case, we want to know if the item or the game object that's colliding with our reset zone is the boulder, in case we have other objects that may interact with this zone in the future. So we need to do an if statement by typing if, open parentheses, and we'll say collision dot game object to get the game object that's colliding in our reset zone equals boulder. Now anything inside these curly braces means it's true. So if it equals boulder, then do this. Do something. You can put else, do this. Put it in a comment. Do this. In our case, we don't want it to do anything else. We only want it to do something. And in this case, we want it to update the transform or the position of our boulder back to the starting area. And for now, that's going to be boulder.transform.position equals new vector 3. Just like we did with our platform, we update it when the player moved left or right. But in this case, we're doing it only one time, and we're going to set it to 0, 0, 0. Awesome. Now don't forget to add your semicolon at the end and hit Control S or File Save. Now back into Unity, let's go ahead and hit play. And let's see what happens when we move the platform out of the way, and there it gets reset. But you notice it's going faster and faster and faster because the velocity is not being reset. So let's go ahead and fix that. So back in our script, we need to get a reference to the boulder's rigid body. So first we need to create a variable to store that reference. So that's a rigid body 2D, and we'll name it boulder RB. That way we know this is the boulder's rigid body. Now we could make it a serialized field and drag it in just the same way we did the boulder, but instead we could automate this by automatically assigning it when the script starts up. So we're going to set boulder RB is equal to the boulders dot get component rigid body 2D. Get component is automatically going to get the rigid body 2D on the boulder. Awesome. Now that we have a reference to the boulder rigid body, we can update its angular velocity. So down here we can say boulder RB dot angular velocity equals 0. So we want to set it back to 0. We also want to set the boulder's rigid body dot linear velocity to equal a vector2 dot 0. Linear velocity is a vector 2, so just know you can't set it to 0. You got to use vector2 dot 0. Awesome. Now we can save this, navigate back to our game and hit play and see what happens. Alright, let's miss, and it gets reset, and it's back to 0 linear and angular velocity. Awesome. Hope you're enjoying this tutorial series. If you have a question, please feel free to leave a comment or email me at sweetandsaltygames@gmail.com. In the next update, we'll add some objectives and a basic UI to track your score. See you then.